So hi everyone. So here we are going to start with our second unit. So before this, here I would like to introduce you here that this video is for St. Thomas School Ranchi for class 9 student for physics, and this is the second chapter of physics, which is motion in one dimension. Under this chapter we are going to start the first unit, which is scalar and vector quantities. What is scalar quantities and what is vector quantities? First, as you might be knowing it, that in a scalar quantities is a kind of physical quantity which are expressed only by their magnitude. Means that a scalar quantity does not have any direction, it has only magnitude. But we have the second quantity which is called as vector quantities. This is a quantity, physical quantity, which has magnitude as well as direction. So this is the first topic given here, which is scalar and vector quantities under this chapter, motion in one dimension. Now next come to second topic. So now here we have the second topic, which is rest and motion. So as we all have studied even in class 7 that what is rest and motion. So with respect to surrounding, change in surrounding, with respect to time, okay, if an object is going to change its position, then we say that that object is in motion, and if it is not going to change, then that object is in rest. But here the new thing we are going to study about this rest and motion is about the inertia, which we are going to study further. So this is about rest and motion. So next topic is distance and displacement. This is also new for class 9 students, which we have not studied in class 7 and 8. So here this is the new thing, what is distance and what is displacement. So this is the distance, means a total path covered or total path traversed by an object when it start from a point A to B point. It goes in different directions, okay, in different direction it will go, okay, and while going from this to this position, whatever the path it has covered, the total path covered is going to give us distance. But the displacement is the shortest distance. As you can observe that this object has started from A and then it has reached to B. The total path traversed by this object is called as distance, but this displacement is the shortest distance between A and B, which is always straight. And you can see that when we draw a straight line from A to B, it gives one particular direction. Thus displacement becomes a vector quantity, but distance is a scalar quantity because displacement comes with magnitude as well as direction. But in distance we have only its magnitude, but we do not have any direction. So distance is a scalar quantity. So next, another topic is given here as speed and velocity. To say speed and velocity also have the same differences, that is speed is the rate of change of distance with time, but it does not have any direction. But what is velocity? So velocity is a rate of change of displacement of an object with respect to time in particular direction. So that is called as velocity. So it is given as velocity of an object is the distance traveled per second by an object in specific direction. So this is a velocity of an object. Further, different types of velocity is given. Non-uniform velocity is given, instantaneous velocity is given, average velocity is given. Then again, after speed, knowing the speed and velocity, we have to understand the topic which is called as acceleration and retardation. So what is this acceleration and retardation? Here when we say about the velocity, suppose we have started our scooter, we have started with 10 km per hour, then further after few seconds the speed increases to 40 km per hour, then after few seconds the speed increases to 60 km, again further it has decreased to 15 km per hour. So what do we are observing with when the time proceeds, that our velocity decreases and increases with respect to time. So here it comes about the acceleration, which states about rate of change of velocity. Acceleration is the rate of change of velocity with time, okay, which is, and further with numericals relation, it is denoted with a and final velocity denoted with v, and initial velocity denoted with u divided by t. So acceleration becomes v minus u by t. And what is retardation here? So retardation means a negative acceleration, means that when the speed decreases, okay, that time we call that it is retarding. So this is your first unit. So under the first unit we have seen first, again I am giving the recap of the first chapter, that it is scalar and vector, the first topic we have studied. Second topic, what is rest, what is motion. Third topic, we have studied what is distance, what is displacement. Then the fourth topic, we have studied what is speed, what is velocity. So with this we have completed this first chapter. One more topic, acceleration and retardation. So these are the 5 topics we have studied under first unit. Now next come to the second unit, and this part is very new for you all class 9 standard student. Graphical representation of linear motion, means graphical representation of motion in one dimension or motion in a straight path, that is linear motion. So first we are going to study about the graph which is called a displacement time graph. Means that what is this displacement time graph? Means displacement we are going to take in y-axis and time we are going to take in x-axis. Suppose an object is in a motion. So when an object is in a motion, it is going to start moving from one place to other place with respect to time. So here the tabulation is given that in first second how much distance it has covered, in second second how much distance it is covered, in third second how much distance it has covered, in fourth second how much distance it has covered. So here we have different cases. So when an object is a stationary object, its graph will be at the same position. So this graph will be parallel to x-axis when the object becomes stationary. And when this graph, what you are observing of distance and displacement and time graph, that it is in a straight line here, inclined straight line, you can able to observe here. So this graph shows uniform velocity, means that what you are observing, that in a case of this kind of example, that at every second the object moves with uniform displacement, that is called as uniform velocity. This graph shows about the uniform velocity. So two graph we have observed, this is for a stationary object, and when an object moves with a uniform velocity, it becomes a straight line like this. And further, another example, what you're observing, this is a curved graph. Under this graph, when an object is having a variable velocity, means that at every equal interval of a time, the object does not moves with uniform displacement. For example, it is given at second it moves with 10 meter displacement. Then again in fifth second, it displaces to 30. So there's a difference of 20 meter in displacement. Then again in sixth second, it had displaced to 47, which is a difference of 17 centimeter. Thus the graphs comes with curved line. And now what is the use of this graph? So use of this graph is that when we are going to find out the slope, this is called as slope, that this is delta y, and this time from here to it is called as delta x. When we are going to divide delta y by delta x, we are going to get the quantity, means displacement by time. We are going to get the quantity which gives us, see here the calculation is given. We have divided y-axis and x-axis, and here we got the quantity which is velocity. So with the help of displacement time graph, we find velocity. And here this is non-uniform velocity. To find out the slope, what we do, we take one point, then we draw a straight line like this, and then we draw complete a triangle, and then we will find out delta y, and here this is delta x, and then again we will divide these two quantities, we will get the quantity which will gives us velocity also. So this is about the displacement time graph. Next quantity is velocity time graph. So here in velocity time graph, we are going to take velocity in y-axis and time velocity in y-axis and time in x-axis. So here you can observe that different velocity has been given for different time duration, and the graph comes like this. So what is the use of drawing this velocity time graph? With the help of this velocity time graph, we can able to determine distance covered by an object or displacement of an object. How do we find out this distance and displacement? With the help of velocity time graph. Here suppose this is the graph. What you're observing, that when we have completed our graph with the help of tabulation, you can observe that this part is given as a triangle, this part comes as trapezium, and again this part comes as trapezium. When we are going to find out the area of these all figures, then we can able to find out the distance. And when we will subtract, for example here it is given, to find out the displacement, what we are going to do, we will add this two and we will subtract the negative part, then we will find out the displacement. So with the help of velocity time graph, we can find out distance and displacement of an object. By adding all the areas, we can able to find out the distance, and then by subtracting the negative side of the graph from this two part, we can able to find out the displacement. So this is about velocity time graph. The different kinds of velocity is given here with an example, and some numericals are given. And now next comes to acceleration time graph. So here this graph is drawn for freely falling object, which is a good example of acceleration. When an object falls from certain height to the ground, so that example is given, motion under gravity. So in that case, what is going to happen here, that the object is going to get down with uniform acceleration. Thus the first graph which is going to come here for the acceleration time graph, which is uniform acceleration. Thus it is in a straight line in x-axis. This is uniform acceleration. Then we have converted the acceleration time graph to velocity time graph by finding out the area of every part. You can observe that there are 1 2 3 4 5 rectangles. When we'll find out the area of separate 5 rectangles, okay, these are the 5 rectangles, we can able to find out the different velocities. Means that in an acceleration time graph, so acceleration is equal to v minus u by t, and when we are going to multiply a into t, we are going to find out change in velocity. So means that when we have multiplied, means when we found out the area, means that we have multiplied a into t. What quantity we have found? We have found out the velocity, and then we are going to draw a graph of velocity time graph. And as we have studied further, with the help of velocity time graph, we will find out the area of each triangle here, 1 2 then 3 then 4 then 5 triangles. We can able to find out the displacement. Then further again we have drawn the graph, which is displacement time graph. Then what do we are observing, that this line does not come in a straight path. This is a curved line. Then to make it straight, what we are going to do, we are going to make it t square. And when we have made it t square, it comes straight. And further, then it becomes displacement by time square graph. And then we will find out the slope of this line. Means that when we are going to find out the slope of displacement time graph, we know that we can able to find out the velocity, which is here rate of change of velocity, which is going to come as 5 meter per second square, which we are going to make a square of this, and then we will get the answer as 10 meter per second square, because this is displacement time square graph. So this is all about the graphs in this second unit. The second unit is all about the graph. First we have studied about displacement time graph. Secondly, we have studied about velocity time graph, and then third quantities which we have studied about the acceleration, time, and tau. And based on this, we are having a different graphs given here. 1, 2, 3, 4 different graphs are given, and then we, in some cases we have to find out the area, in some cases we have to find out the slope of this, and we can able to very well find out the quantities like speed and distance and displacement. So thank you everyone with this, and this is the numericals and theories are given based on this session. So thank you everyone, and we have completed the second unit here today, which is motion in one dimension. Thank you.